Here's the Chemistry 1 video covering significant figures. So in chemistry, we don't really deal with numbers per se. We have a joke that we say that numbers are for math and math is hard. They don't like us saying that, but whatever. No, in chemistry, we deal with quantities, and quantities are different than just numbers because a quantity is something that you measure, or it can be measured, and contain both the number as well as a unit. Essentially, chemistry and science in general is math with a purpose. Math says 2 plus 2 is 4. Science explains why are we adding 2 plus 2 to equal 4 in the first place. When we're dealing with measurements, only some numbers matter. We call those numbers significant figures. Significant figures are a really important portion of chemistry and science in general. Because of a couple things that we'll talk about at the end of this video. But when we are talking about significant figures, they include all of the known values that you are 100% sure of, as well as one estimated number, one unknown number. And we'll give some examples of known versus unknown numbers here in just a second. So here we have some rulers, 3 rulers, A, B, C, with different measurements on it. So a measured quantity, we're going to get because we can measure it, it's a quantity and not just a number. It's going to be a number with a unit. So if we're looking at ruler A, we have a mark at 0 centimeters and we have a mark at 10 centimeters. We can't be 100% sure where 1, 2, 3, 4 centimeters are when we're using ruler A. But maybe that's all you have. That's the resource that you have, so you have to use it. You can't know any numbers, but you're allowed to make one estimated guess. It looks like it may be somewhere between 3 and 4, so we're just going to guess 3. Using ruler A, the best guess that we could get is that piece of wood or whatever we're measuring is 3 centimeters long. Maybe someone comes along and says, oh, well, you have a really cruddy ruler. Here's a slightly better one. This one has marks every single centimeter. And you can see 0 centimeter, 1 centimeter, 2 centimeters, blah, 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 blah. With ruler B, you can now be 100% certain that you are at least 3 centimeters long. You know for a fact, 100%. You could argue until you're blue in the face. 100% confident that that thing is 3 centimeters long, which means you know that it is 3 centimeters. But the difference between A and B is with A, we weren't sure. We were already making a guess. You have to make a guess. With ruler B, we are knowing that it is at least 3 centimeters, but we still have to take a guess. Now, we don't have the little marks to prove exactly where it is, but it looks like it may be 0.2, 0.1, let's say 0.1. So our guess this time is going to be 3.1 centimeters. We went to what we knew for sure, 3, and then we went 1 unit further, 1 decimal further, 3.1. Now let's switch it up again. Instead of ruler B, we're going to use ruler C. Ruler C not only has the centimeter marks, but has millimeter marks. We can be a little bit more sure of our answer. We are still sure that it's past 3 centimeters. That's what the ruler says. But now because of those extra little tick marks, we can be sure that, oh, hey, that's at least 3.1. I can take that measurement, I can compare it to the ruler, and I can argue with anyone who wants to walk into my door, this thing is at least 3.1 centimeters long. I'm not guessing at that. I know it. The ruler says it is 3.1, but you always have to take a guess. So we're going to go 1 decimal further. I know that I have at least 3 centimeters. I know I have at least 3.1 centimeters. It looks like maybe it's between 0.1 and 0.2, so we're going to say 3.15 centimeters. So this is maybe about halfway. I'm not sure if it's about halfway. Maybe you want to come in and say that it's only about a quarter of the way between 0.1 and 0.2. That's okay. That's your guess. But you are allowed to estimate and have to estimate 1 digit. We guessed with our 3 in ruler A. We knew 3 there, and we guessed that 0.1. With ruler C, we knew 3, we knew 0.1, so we guessed that 0.5. It's a pretty safe assumption if we ever give you a problem like this where we say, hey, here's a number, circle what you know of and underline what you don't. The last digit you see will always be your estimated value, your unknown value, the value that you guessed at. So with that first example, 7.6, you are guessing at 0.6. Which means if you're guessing at 0.6, you had to know for sure that you had at least 7 centimeters. That's something like ruler B. You could know the 7, but you didn't quite know the 0.6 for sure. So you had to make a guess at it. Next one, 2.34. You are guessing at that 0.04 at the very, very end, which means you have to know the 2.3. You know because your ruler says this is at least 2.3, and you could prove it. You have the mark to prove the 2 centimeter. You have the mark to prove the 0.3 centimeter. That's something like ruler C. Last but not least, 15. Now, when you look at that, it's always going to be your last digit, which means we're going to guess at that, the 5 part of the 15, the ones place, which means you have to know for a fact that your thing is at least 10. Well, if you look back at your A ruler, you have a mark at 0, you have a mark at 10. If you had a long enough thing that you were measuring, you could prove that this thing is at least 10 centimeters. But if it's somewhere between 10 and 20, and you're not really sure where it falls between 10 and 20, maybe 15 is your best guess. You know it's at least 10, but maybe you're guessing it's about halfway. Well, that's where the ones place would come in. This portion isn't in your notes, but we will be using balances a lot in the lab, and we'll be doing a lot of measurements. Balances are nice. If you were using a balance to weigh a mass of an object or a chemical or a compound, whatever, balances have that last estimated value built in. In other words, whenever you're using a balance to measure a mass, you are going to copy whatever number is on the screen. You're not going to add an extra number on the end of it. You're just going to copy exactly what's on the screen. The reason that you can copy that, and if you've ever used a balance before, sometimes it does that jump up and down. Maybe it's 1.17, then it turns into 1.18, and then down to 1.16. That's because it's constantly trying to estimate that last digit. Just copy down the number. One of the numbers is on that screen, and you'll be good to go. Okay. So, talking about significant figures. Why are significant figures important? Why do we care? Well, I have a number there. 2 grams versus 2.00000 grams. Those are effectively the same number. But the difference is having those more significant figures means you are more confident in your answer. In other words, with that 2 grams, you're estimating it's about 2. But if it's 2.00000, the only number you're guessing at is that last 0. You're confident about everything else there. You are sure that it is 2.000, and you're guessing at that last 0. Which means more significant figures means more precision. And we'll talk about the difference between accuracy and precision here in just a second, but know that more significant figures means more precision. Now the question is it more accurate? No. I mean, we talked literally when we opened this portion of the slide, those are the same numbers. 2 and 2.00000 is the exact same value. The number is effectively the same. The difference is we're more confident in that second one. So is it more accurate? No. And we'll talk about how we determine accuracy here in just a second. Last throwback to the rulers. You had ruler A, ruler B, ruler C. The ruler that was the most precise was C. It was the ruler that gave you the most confidence in the measurement of that length. So what is the difference between precision and accuracy? Accuracy is correctness. In other words, let's say I measure my mother, or your mother, whatever, to be 6 foot 2 inches tall. How would I know if I measured that accurately? What would I need to know? Well, you'd need to know the true value. You would have to know whether or not your mom is actually 6 foot 2 inches tall. If she is, then yeah, you did measure accurately. Well done. But if you measure your mother to be 6 foot 2 inches tall and your mom's actually only 4 foot 4, no, you didn't know that. You didn't measure accurately. You have to know the true value in order to determine accuracy. Precision is repeatability. Can you get the same measurement over and over and over again? So let's say measure my mom to be 6 foot 2. Then you come back in like 5 minutes and you measure again. This time you get 3 foot 7. Then you measure her again, and now you're 5 foot 2. Those three measurements are nowhere near each other. You're not being precise. Precision means repeatability. If you were to be precise measuring my mother or your mother, whatever, you would have to get 6 foot 2 every single time. If you're able to get 6 foot 2 over and over and over and over again, then and only then can you say that you're being precise. Here's a picture kind of to help you understand the difference between precision and accuracy. If we're going to look at the top left, this guy right here, accuracy is, are you dead on the target? Are you in the bullseye? Are you hitting the bullseye? That's accuracy. Well, with number 1, the top left, yeah, you're hitting the bullseye. You are being accurate. It is a separate thing to be precise. In order to figure out if you're precise, you have to ask yourself, okay, am I hitting the same spot? Am I repeating the results that I'm getting every time I take a shot? Well, with that top left one, not only are you hitting in the center, you're hitting the center over and over and over and over again, repeatedly. You're hitting around the same spot. So for that first one, we would say that you are both accurate and precise. Let's look one over to the top. So in the top right, again, 2 separate questions. First question is accuracy. Am I hitting the center of the target? No. You're not hitting the center of the target, so you're not accurate. It's that simple. Then you can go to the second question. Am I being precise? In other words, am I hitting the same spot over and over and over again? So when you look, hey, all of my shots are in about the same place, which means I'm being precise. I'm hitting over and over and over and over again in the same spot. I'm being precise, but I'm not hitting in the center of the target, so I'm not accurate. Now let's look at the bottom left. Okay. First question, am I being accurate? Am I hitting the center of the target? This one's a little confusing. And we'll never really give you one that looks quite like this, because when we talk about accuracy, we talk about all of your points averaged together. So this guy and this guy kind of count each other out. This guy and this guy kind of balance each other out. This guy and this guy kind of balance each other out. So we would actually say that that bottom left one is accurate. I know it's weird. I know it seems wrong because, oh, well, you're not hitting the center of the target. You're hitting the red portions. I know. We're never going to give you an example where you're only accurate. But then you can move to the second question. Am I being precise? That one is really, really, really obvious. Because look at that the bottom left target. Are you hitting the same spot over and over and over? No, you're all over the place. Some are to the left, some are to the right, some are above, some are below, some are right and center. They're all over the place. So that thing is not being precise. It is only being technically accurate. Again, if that's weird or confusing or you disagree, don't worry about it. We're never going to give you that bottom left example. Last but not least, the bottom right. First question, am I being accurate? Well, even if you kind of average all those shots together, you still only get to be about there. That's not accurate. That's not accurate at all. You're nowhere near the center of the target, so you're not accurate. Then you look at precision. Are you hitting the same place over and over and over again? Same idea as that bottom left. You're all over the place. Some are in the blue, some are in the red. You got one that's kind of in the yellow there in the center. So not only are you not accurate, you're not being precise. That's neither. Okay, so it's another visual representation to kind of help you with this idea of accuracy versus precision. Please, please, please know they are not the same thing. You need to have an understanding of accuracy. You need to have an understanding of precision.